morning. My name is Carrie. Together with my colleague Nima, we will be spending the next couple of hours describing and familiarizing you with the IEDB search interface. And I'll start by putting us in the context of the larger day. You've heard already from Bjorn about the scope and the history of the IEDB, which gives you an idea of what we do, what we don't do, and how it's done. And very importantly, then you heard from Randy, who told you about the content and the organization of the data that's in the IEDB. And it'll become abundantly clear to you why we spend a little bit of time telling you about that, because how you query for the data and how you think about querying for the data goes to how the data is organized and how it's captured. So that's very important. And then later on in the day, Bjorn will come back and give you a brief introduction into tomorrow, which is about the analysis resource. So I'll start by giving you a brief overview of our part of the talk. So it's divided into three parts, punctuated by breaks and lunch. The first part, we will be exploring the homepage search interface, details, functionality, so on and so forth. I'll show you the query results page and go through details of that, and talk to you about finders. What are finders? What are they for? Then Nima will come in and explain the specialized searches. These are detailed searches that allow you to do just about anything you could ever want to do and more. There'll be some additional features covered. And then after the break, I'll talk to you, introduce the Immuno browser, talk to you about how that works and how it was developed. And then we'll do some example queries. Now, the example queries will be first done statically. So they'll just be screenshots to walk you through how it's done. And then after lunch, we'll come back and do exercises, so follow-along exercises and live exercises using the database so you can see how it works in action. So, without further ado, detailed overview of the search interface. So first I want to ask you guys, get an idea of your interests and needs. We did an initial query of what your interests are and where you, what things you're interested in and your level of expertise, so to speak, with the database thus far. How many of you have used this site? Pretty much all of you. Anybody not used it ever? All right. I want to understand the balance between how many people are interested in just doing queries and using the database for understanding what is already out there from the literature, just queries. Are most people interested in queries and tools? I'm assuming. Okay. If you're just interested in tools, hopefully by the end of the day I'll convince you that you also can use the database to do queries, because a lot of times, as Ward alluded to, they go hand in hand, and it was developed for them to go in hand. Very often you'll find that you want to go in and do a prediction and you think you need to do everything. Sometimes you don't need to reinvent a wheel. Sometimes there's a tremendous amount of data already in there, and I'll show you an example of that later when we do live exercises, especially for flu, HCV, tuberculosis. There's a lot of data already in there, a tremendous volume of data. Have any of you done any downloads of the Excel format to look at the data? Yeah? Has anybody downloaded the whole database? Yeah, a couple people to do informatics. Okay, and are there any people that are interested in licensing? It's free for academic and nominal fee for, and if you are interested in licensing, you can talk to Ward. All right, so you've already seen this. Both Bjorn and Randy have showed you the 3.0 homepage. I'm just going to go over it real quickly here. So today is the left-hand side. Am I right from left? The left-hand side gives you a quick overview of what it's about, the scope of the IEDB, and the metrics. These are things you've already heard about from both Bjorn and Randy. The center part, which is what we're going to be discussing today, is the IEDB search interface. And then tomorrow, you'll be hearing about the Epitope analysis resource. Randy's already discussed the other items, the ability to check, to provide feedback, and also get help at the top and bottom of this page, and then to find out how frequently it's updated on the right-hand corner. So we will start here on the IEDB homepage. The main query interface was designed, the main interface that is located here was designed to be streamlined. And what it provides is a streamlined version of the overall query functions that we have in the IEDB. And it covers 6 main elements of the data. And you've heard a little bit of this already from Randy, and I'll go into detail about what we mean. There's a few features here that I want to point out. There are radio buttons. We're all familiar with that. That allows you to toggle on things of particular interest. There are free text fields that have an autocomplete function, which I'll show you in a minute for those of you who are not familiar with that term. And also some checkboxes. There are a few things. There are a default. So the default, if you just did a search now, the default is any epitope, any host, any assay, all responses, and also positive. You can see some of these defaults. And again, I'll go through, as I go through each one of these search panes, you'll see the details of that. While the vast majority of the searches you might want to perform can be done here, we do have additional functionality, additional search panes that provide additional functionality, and I'll show you that in a second. But I want to walk through each one of these search panes. So the epitope, of course, you want to be able to search by epitope. So you can search by the sequence. You can search by different homology levels of that particular sequence that you may have typed in. You can search for linear or discontinuous epitopes. Similarly, you can search for the antigen from which the epitope came from. You can search for just the organism from which the epitope came from, because every epitope comes from some protein or other molecule. Obviously, the host, you can search for human data. You can search for animal models of human data. And as both Randy and Bjorn explained to you, that we're very much a database of assays, even though we are an epitope database. And here you can search at the high level. So you're searching for T-cell responses, B-cell responses. And you also can search for ligand elution. And the ligand assays, that means binding data and peptide elution data. Similarly, MHC, you can search at the high levels for class 1, class 2, and non-classical. And then finally, also, you can search by disease. And these represent the 4 high-level disease categories that are in scope for the IEDB. Now, as I mentioned, while you can do the vast majority of your searches from this home page, we do have these same search panes with additional expanded functionality if you are to go click here and search and go into the results page. And then you'll see here, along the left-hand margin, the search panes are repeated. And they're repeated here for a couple of reasons. Number one, it allows you to refine your initial search. So say your initial search was just looking for influenza, and you come in here and you find that you've got 4,000 epitopes. That's a lot of data. Maybe you want to refine that search. So you can use quickly, without going backwards, you can use these search panes along this left-hand side to do that. Also, you can use these search panes here because they have expanded functionality to do more complex searches. For example, a specific type of assay. So not just a B-cell response, but a specific type of T-cell response, say neutralization or protection, something like that. And then finally, from here, you are able to do specialized searches, and this is what Nima is going to be talking to you about in a few minutes. Now, later I'll go into more detail about this results page and talk to you about different features there and different elements of that. But for now, what I want to do in the next series of slides is I'm going to walk you through each one of these search panes, starting at the top with Epitope going all down to the bottom, so you can see where they are, what they do, and what you can do with them. So starting at the very first search interface, one of the most common queries that are performed on the IEDB, and we know this from metrics that we run, is epitope sequence search. And this search pane allows you to either type in a sequence of interest, or you can search for any epitope. As I alluded to, that is the default. You can also choose linear, specifically discontinuous, or you can search for non-peptidics, carbohydrates, glycolipids, so on and so forth. You can also do a sub-search of an exact sequence. You can look at different levels of homology, 70, 80, and 90%. So the next search pane coming down the left-hand column is the antigen search. And in the IEDB, the antigen can be the epitope, but the antigen also can be the protein the epitope came from, and the antigen can also be the organism that the protein came from, that the epitope came from. So you get the idea. And this search pane allows you to search either for organisms or for the molecule. In many cases, it's a protein. So the organism can be a pathogen like a virus or a bacteria. It can be a mammal for a self-antigen, for those of you working in autoimmunity, or it can be an allergen source like a grass, tree pollen, that sort of thing. And also, the other feature I want to point out here is that if you start typing in the free text field, you get this autocomplete function, and that's what I talked about from the home page. That is also a function that's on the home page. So the assay search. The assay search allows you, the default is all. Here I've clicked off B and the ligand elution assays to show you just T cell. That allows you to search at the high level for the response type, whether it's a T cell response or a B cell response, or a ligand elution assay or MHC binding. There is also a free text field that allows you to type in ELISA, IL-2, and you'll get an autocomplete as well. There's also a finder function. I'll allude to that now, but get to the details of it later. And then that allows you to get more specifically. This is the expanded function, and so this is contrasted from the main web page where you don't have the finder function. So MHC restriction, one of the unique things about T cell responses, they come in different flavors, so to speak. You can have class 1, class 2, non-classical, and again, you can use the radio buttons to select that, or type in the A2, B24, a serotype or allele of your interest. And continuing down, the next search pane allows you to specify which hosts you are interested in. The radio buttons provide you with the most common ones, and then there are other common ones in this drop-down menu on the main search interface. And then also the expanded one allows you to type in something more specific. The free text field will allow you to get at something like transgenic mouse model or specific mouse strain, something that's less common, but most often you'll probably be searching at the higher level. And then finally, the search by disease. The reason why we're looking for epitopes in the first place. And this is a really unique and nice feature of the IEDB that allows you to search not only at the higher level, but more specifically for particular diseases. So it includes the 4 main categories: infectious disease, allergy, autoimmunity, and transplant. Another unique feature is you can also look for normal controls. So in those papers in which they have studied for allergy and autoimmunity are good examples. They have studied patients with disease and patient normal controls. We also capture that data so you can differentiate and see what's been tested and what's been positive or negative, depending on whether there's been the presence of disease or healthy individuals, which is kind of nice. The disease state is based on the clinical status of the host. So it's if a patient was sick and it was described in the patient history of the paper, or if it's a known model of animal model of human disease. It's not an association, it's not a category of the paper. And it's a unique feature that allows you to get at things like allergy and autoimmunity. It goes without saying that if you're interested in hepatitis, you'll look up hepatitis C, hepatitis A, hepatitis E, or influenza. But with autoimmunity and allergy, there are multiple different manifestations of those diseases, and so it allows you to get at those very uniquely. It's a neat feature that allows you to differentiate responses between the human situation and the animal model that is modeling that human disease. And you can do that using the immunome browser, and we can show you examples of that later. And then finally, just to mention that the disease tree was developed by the IEDB using the disease ontology, as Randy mentioned. So this is the last general topic or element that the 6 search panes represents. So you can search by epitope, search by assay, search by host, disease, allele, or assay type. Now I'm going to focus on going a little bit more into detail to wrap it up into describing the details of the results page. So as I mentioned, from the home page interface, if you click search, you'll end up on the results page, depending on what input criteria you gave. And again, along the left-hand side, there are the repeat of the search panes. And then along the top, you have 4 tabs. And these 4 tabs summarize the data for that particular query. So you have content that is epitope, details of the antigens that the epitopes came from, all of the assays for that particular query, and then the references. And if you can click through each one of those and look at the details, which we'll show you later, In parentheses is the total number of each items, total number of epitopes, total number of antigens. At the top, there's a neat feature that tracks your input criteria. So it's a filter that tracks each step that you've added to that. You can click this on and off depending and repeat your search by hitting the search button again. And then down below, you can change the number of pages views per page. Each one of these rows represents a different record. And a nice feature that's also along the right-hand side is the number of references and the number of assays. This gives you at a quick glance the relative abundance of data for each particular epitope, which is also very nice. You can also sort on this, so you can go high to low or low to high, depending on your interest. To review, the results page is designed to provide a summary in tabular form with epitope tab, an antigen tab, an assay tab, and a reference tab. And again, the parentheses are there to provide you with the summary of the total for that particular query. Each row provides an individual record that is clickable. And by the way, I should say that from any particular point on the results page, you can usually drill down to the content of an individual record from just about anywhere. And you can play with that once you start getting your feet wet on the live database. And again, it's often, many times, as you can see by this large number of epitopes, there's multiple pages, so you can page through down here. And as Randy mentioned, all of what you see on the tab that you have highlighted can be downloaded using Excel, and that's accessible both at the top and the bottom on the right-hand side. So, now in the many of the slides you've seen the word Finder. We've alluded to the word Finder, the idea of the expanded capability of the search panes that are within the results page. And I want to take a little time and explain what finders are and what they mean. And Randy's explanation of how the data is organized goes a lot to how these are. So finders are a unique feature of the IEDB that provide a standardization and hierarchical organization for the data captured therein. And what it does is it allows the user to get at the enormous volume of data that's in there in a very searchable format, and it allows you to do it at any level. So there's we use the word granularity, but there's a high level of granularity. So you can search at any single level. You can search by the epitope, by the assay, by the monoclonal antibody name, anything, by the author, by the reference, PubMed ID. So there's a tremendous number of avenues to get at the data, and it's because we have it very well organized in these trees that Randy showed you. The data trees are an ontological, so if those of you who aren't familiar with ontology, I won't try to explain it to you, but it's the way computers talk to each other, or in the case of NCBI, taxonomy, a taxonomic-based organization with a parent-child relationship. And I'll show you what we mean by that. This is the icon here. This is what they look like. And when you click to open those, and I'll be demonstrating those shortly, we use this to organize all of the data in the database. The antigen tree, as Randy indicated to you, is based on Swiss Prot gene accession numbers. The non-peptidic data is organized by Kebi. The organisms, NCBI taxonomy, alleles are also organized, and those are very complex, actually, and the nomenclature for those are very complex. So having them in a searchable data tree, it makes it very difficult, makes it not difficult to get at them. The assays are organized by response type and the category of response that you get, and then the disease tree also is available to allow you to search the different types of diseases by specific names. These are work behind the scenes, but they're also accessible to you, and that's why we take the time to explain them to you and show them to you, because they help you query probably with a little bit more precision. So how do you get at them? As I alluded to, they are not on the main web page. So from the home page, you click Search, click the Search button, and that brings you to the results page. And if you move the mouse down the left-hand margin of that page, you'll see each of these search panes will expand. And as they expand, it reveals the Finder button. And what I'll do in the next series of slides is I'm going to walk you, starting with the very first one you would encounter from top to bottom. I'll walk you through each one of these finders to demonstrate the functionality and show you what they look like and how they work and how you can use them to get at your information. So starting at the top, the non-peptidic epitope finder allows you to search for non-protein chemical entities that have been shown to bind with B and T cell. These are drugs, metal allergens, things like polysaccharides from bacteria, glycolipids. Many different other things react, obviously, with the immune system in addition to proteins. So the overall organization here, you'll see this window pop up when you click the finder. This window will pop up. They all look very similar, but there's some details that I'll talk about that are different among each. The ability to write in the name, the ID if you happen to know the KEBI ID, and then the ability to click search. When you click search, what you get is a list of matches to your search down below in a table format. And then over here to the left, to the right, sorry, again, I'm getting dyslexic here. There's the tree, and these are the data trees that are available to you to browse. So if you want to hunt through them and look at and see what data is there, these trees are there to allow. There's also another feature that I'll show you that you can highlight these particular entities in the tree, and I'll show you that in the next couple of slides. So the next finder that you'll use probably more than any finder is the Antigen Finder. And the Antigen Finder allows you to search for the epitope source. So in the case of an organism, say it's an epitope from flu. The immunogen, if you're interested in finding organisms or people that were immunized with influenza, say an influenza vaccine, then that immunogen would be an organism. Or similarly, the assay antigen could be the organism. In this case, I've clicked open the finder and typed in HCV here and clicked search. And you'll see I got a list in the table down below. I got a list of possible hits that match HCV. And then, of course, the tree here, you can peruse to open up the organism branch to that tree and look for viruses, bacteria, depending on what your area of interest is. Once you've done that, there are then two options. As you can see, there's these icons here. One is a plus sign, a green plus sign, or a white plus sign and a green black background. If you were to click that, you are selecting that particular record. And it'll appear up here, and then you click apply, and that will add that to your search parameters. Alternatively, if you're interested in seeing what else is there for HCV, you can click this icon here, which is highlight in tree. And when you click that, you see that HCV appears in the tree in its family of viruses, and then I've clicked it open to show you all the different genotypes that are underneath that. Then if you go further to click open one of those, you can see that within the genotype 1, there are all the subtypes of HCV within there, and you can continue to click down and see all of the content. So you can see very quickly how a tremendous amount of data is gathered in one spot for you to look at and access in the form of a data tree. So I wanted to give you an example of that. So the molecular finder, so a little bit of jargon that we use the term molecule finder to distinguish between an organism. So we can say that obviously there's antigens that are epitopes, there are antigens that are a protein, and there are antigens that are an organism. In this case, an antigen that is a protein antigen is a molecule, so we call it the molecule finder. So it's just to explain that. So again, the molecule, the epitope source protein, you can also have a protein used to immunize an animal, and you can also have the assay antigen be a protein, a recombinant protein on an ELISA plate or run on a Western blot, that sort of thing. So similar to what you've seen before, you have the ability to type in the protein name here, and you also, the difference here is you can also enter the organism that goes with that. This helps you in cases where you're looking for a protein where the name is in multiple different organisms. HA, there's more than one HA, there's more than one core protein, there's more than one nuclear protein. So if you want to specify and tighten up your search criteria, you can specify both the organism and the protein name here. So if I do that, if I type in HA and influenza, I get down below a list of potential matches to that input. Again, you can sort on the rows on the top. And then again, you can click Highlight in Tree. You can either choose one by hitting the plus sign, or you can click Highlight in Tree. And when you do that, you get, again, the high node relationship with all the children GI numbers underneath. And so if you were interested in this case, if you're interested in doing a search for all HA from all influenza, you would want to pick the high node and not one of the individual, because you'll only get the data from the individual ones. So you would pick the high node. So that gives you an example of what the molecule data tree looks like. So the Assay Finder. So if you're interested in looking for something more specific in the broader category of T or B cell responses, you can use this finder. So if you click Open the Finder, again, you'll get the ability to type in the names. And then this particular finder has added functionality. And Brandy alluded to this and showed you some of the distinctions of the details, way you can get at some of the data. You can search here by method using this drop-down method. So you can look specifically up chromium release assay, tritiated thymidine proliferation, ELISA spot, so you can look that up by name. But the other neat thing is you can use the measurement of. So if you're interested, as she pointed out, in a particular cytokine response, say gamma interferon, there's lots of different ways to measure gamma interferon. So if you use this, you'd have to do one at a time. But if you use this and choose gamma interferon, you'll get ICS, LE spot, ELISA, all the potential methods that have been captured to date for measuring gamma interferon. So that's kind of a nice element. And then the tree, the data tree, categorizes everything based on the activity defined in the assay itself. And the Allele Finder. The Allele Finder looks very similar, but again, we have these added drop-down menus that allow you to search by species, by class, or by serotype or specific allele. We currently have 15 species, so we have data for about 15 species, which adds up to a tremendous number. Do we know how many alleles we have? Hundreds. Many, many, many alleles to choose from. And again, the tree, the data tree for this is actually really, really nice to allow you to search through by species, by serotype, and click through. I encourage you to click through that and get familiar with that when you have a moment. Host Finder, fairly straightforward. Most cases, you'll be looking up rodent data or human data. What this is nice for is to allow you, most often, and what I use it for, is to look up very specific mouse strains. That's one of the more common things you might use. But again, type in the name or the ID. You do not need to type in both, but I just put that there to show you the example then. NCBI ID for human. And similarly, click the plus sign to apply it to your particular query. And then the Disease Finder. The Disease Finder, again, allows you to look for the higher categories, the 4 categories that are in scope for that IE, but it also allows you to look at very specific ones like rheumatoid arthritis or asthma. And in this case, as an example, I typed in asthma. The disease tree is actually very helpful because it allows you to peruse through the different categories of disease that we have, so you just see what's there. Also note at the bottom there's a node for healthy, normal controls, and that allows you to differentiate between reactivity in things like autoimmune and allergy. And then finally, before I turn this over to Nima, at the very bottom on the left-hand margin of the results page is the ability to search for reference information. So if you're interested in a particular author, a particular lab, or you have a PubMed ID that you're interested in, or you want to look for your work, this is the way you do it. And this screenshot I did of PubMed is just to show you all the different data details that can be input here into this search pane here.